this one, or is this?
Thank you, Zach. All right, so let's see if we can find the null space of this freaking weird 2x4 thing. All right, so this 2x4 thing maps R4 to R2, and we know that the null space is going to be a subset of R4. So I am dead certain that I am looking for some four-dimensional vectors. You guys good with that? Okay, next thing. What? What do I do? What's the null space?
So I augmented this matrix, let's call it A, by 0, 0. Then I did the new row 2, and then I started row reducing. I said the new row 2 is equal to the old row 2 minus 3 times row 1.
Okay, so row 2's new version is row 2 minus 3 row 1. Okay, right. So 3 times row 1 is minus 3, minus 6, minus 6, minus 12, 0. And then if I go ahead and execute, I'm going to get 1, 2, 2, 4 augmented by 0. And feels like 0, 2, 0, 4, 0. You guys all with me on that? Okay, now what?
This is where I'm kind of iffy on my step, but I did the new row 1 is equal to the old row 1 minus row 2, but I'm very uncertain.
Yeah, no, that's good. This is not strictly speaking necessary, but does definitely work. So let's do it, just because. So the new row 1 is the old row 1 minus the new row 2, or minus row 2. All right, so I'm going to leave my row 2 alone. And in row 1, I'm going to have 1, 0, 2, 0, 0. Okay, cool. Now, how many pivots does this thing have? Can you see that? How many pivots are here? 2?
That's what I was going to say.
Yeah, good. So there's 2 pivots. So I'm going to think to myself, all right, self, the pivots are probably important. I'm going to kind of keep those chilling. And I'm going to think about the other stuff. So this stuff feels extra. You guys see that? So if I think about the equations there, that top equation here reads x plus 0y plus 2z plus 0w equals 0. You guys with me on that? And the second equation reads 0x plus 2y plus 0z plus 4w equals 0. And now I'm just going to make my life a little bit easier and think to myself, all right, so z and w are free variables, right? You guys all see that? They're going to determine x and y here. So from this first equation, I'm going to pick let z be 1 and w be 0. And then that's going to give me, right? So, sorry, that was one choice out of, I said from this first equation, but from these equations, I'm going to first pick let z be 1 and let w be 0. You guys with me on that? So then what are x and y?
X is negative 2z.
Good. So it's negative 2 because z is 1. And what about y?
Y is 0.
Let's see. So, yeah, so if W is 0, then that means Y is 0, right? Is with me? So this vector here, the vector represented by these four things, is in the null space. So this is the vector -2, 0, 1, 0. Goes on board. Now, that was only one set of choices. What's the opposite set of choices? For those free variables, I let z be 1 and w be 0, right? Let's reverse that. Let's let w be 1 and z be 0. Now, you don't have to do it this way, but this makes things really easy. If you just go through your free variables and 0 everything but one of them at a time as you go through, it'll make your life a lot easier. So I picked z to be the first one, then I'm picking w. Now that's going to
clarify free variables.
These extra columns.
Okay.
Anything that doesn't have a pivot in it is going to represent a free variable. This is a little bit like, essentially what's going on here, right, is I have two equations and four unknowns. You guys recognize that's kind of what I started with here. So if I started with two equations and four unknowns, there were going to be two free variables at least, right? There might have been more. There could have been four. Right, in the case that both equations were all zeros, right? If this was the 2x4 0 matrix, then I would have no equations and four unknowns. So then I would just have all four free variables. It's possible that I would have two copies of the same equation, then I'd have three free variables. Or in this case, I might have two, right? Which is the least I can get. You guys recognize that? All right, so if I let w be 1 and z is 0, then what's x and what's y?
X is 0.
Good. X is 0 because z is 0. And y is?
-2.
-2. Okay, that feels like the same vector, right? What's actually different about this one?
Switch the x and y.
Yeah, the x and y and the z and w are all switched, right? So it's 0, -2, 0, 1. So my null space is the span of the two vectors that I got here. So it's the span of -2, 0, 1, 0 and 0, -2, 0, 1. Right, so it's the set of all linear combinations of these. Another way you could write this, right? If you didn't want to do this let z be thing and let w be thing, this first one you can think of as being times z, and the second one you can think of as being times w. So you would get, it's the set of vectors that look like something times this first vector plus something times the second vector, which is the span. I find it easier to use the span here. Is any of that making sense? Or am I crushing your brains today?
I was able to get the first one just fine. I guess I don't really see the relevance of the second one. Is it just that it's a different way to get to 0?
Yep, exactly. So the null space is all the things that get mapped to 0, right? Not some of the things. So what you did by finding the first one is you proved that there's no inverse to this matrix. Right? As soon as the null space contains something other than 0, you know it's not invertible. So that's good progress, right? Like, you know something more about this matrix than you did a minute ago. Now, my expectation is that the null space has at least a couple things in it for one and only one reason. This is a map from R4 to R2. Right? This is taking 4-dimensional space and putting it into 2-dimensional space. Are you going to lose something in that process? Seems like. Probably you're going to lose at least 2 dimensions worth of stuff. Well, where's it got to go? Well, it's got to go the only place it can, which is to the 0 vector. Right, so the way that we're going to fit 4-dimensional space into 2-dimensional space is we're going to smash at least 2 of the dimensions out of it. So my expectation here, and we'll get to the counting theorem next time, but the expectation is that you would get at least 2 dimensions worth of stuff here. You guys good with that? Okay. All right.
Hey, Joe.
Yes, sir.
So why are we not saying y or x is 1 and z would be -2?
X is so.
Oh, wait, never mind.
Okay.
I see what you did.
You should get a scale. So you will get a scalar multiple if you pick the other thing. So you could certainly choose the pivots and then let the free variables fall into place. I like to pick the free variables and then determine the pivots out of it because it's more reliable. If you pick the pivots and then let the free variables fall, it's possible that you'll miss something. It's not super duper likely since you guys are pretty bright now and you're good at algebra. But if you're worried about being bad at algebra, pick the free variables instead.